I'm pretty sure you can do that one on your own again. So let's go to this one. So we're gonna sketch the graph. In some places, they'll make the kind of table off to the side for you guys to fill all the information in. If you're careful and you put it all in the graph, I'm okay with that also. Additional points, this is what I was talking about. If I took the calculator away from you, you would have to plug in some of your own numbers and do what's called point plotting to try and figure out where your graph is located. You know, as you draw vertical and horizontal asymptotes, you make these kind of quadrants within your graph, and you would say it's upper right, lower left, and all that stuff. But we're not going to worry about doing that, so you don't have to do that. All right, so take x squared minus 9. Set it equal to 0. It factors into x minus 3, x plus 3. And so we have some critical values, 3 and negative 3. Is there any possibility that my numerator could factor into an x minus 3 or an x plus 3?
No.
No. So those are going to be vertical asymptotes. So 3 and negative 3, whether you label on the graph or put it over in the table above. So what are you going to do next? Horizontal asymptote. What's the degree on top? Second on the bottom. What do you do?
Leading coefficient.
Slant asymptote? No. Leading coefficient rule. They're both equal, so that's a 1 and a 1. So my horizontal would be at y equals 1. So go up 1. Now, when you plug in 0, what do you get? So a y-intercept is when your x value is 0. What happens when x is 0? I get 0. Well, that's also going to be my x-intercept, so I guess we should fill them both in with 0, 0. So did anybody graph this yet? What's it doing? Top left? Fine. Top right? Like that? Good enough? So, one thing you might have heard a teacher say is that your graph can never touch an asymptote. And to me, that's somebody that doesn't quite understand what asymptotes are doing. In this case, the horizontal really talks about long-term behavior. As I plug in larger positive values or larger, more negative values, because we can go back here. Where was it? If you remember, we did this graph back here where our S-shaped curve in the middle actually touched, not only did it touch, it crossed over that horizontal asymptote, right? So you got to really think horizontal asymptotes aren't really going to tell us anything in the immediate space. It's all about long-term behavior, way out to the left and right infinities, positive infinity, negative infinity. That's where horizontal asymptotes give us information. Do I have any symmetry on this graph? Is there a line that I could fold on? If I fold on the x equals 0, the y-axis, so you can say x equals 0 or y-axis symmetry. Good. Does the top factor at all?
Yeah.
Not using real numbers. You could do it with imaginary. So set the bottom equal to 0. Vertical asymptote, x equals 0. What about my horizontal asymptote? I have second degree over first degree.
Divided.
Slant. I'm going to give you a head start on polynomial long division, so I will pause it right now and you will do your polynomial long division, then we'll check your answer. So the x squared plus 1 goes inside the house. Divide by x. I need to put an x up top, so the x times x is x squared. There's nothing to put in parentheses, so just subtract it. X squared minus x squared is 0. There are no x's, so when that drops through, the only thing left will be the plus 1. Well, that's a constant, so it's got 0 degree. I'm dividing by x, which is first degree, so we're already done. One step, right? So that slant asymptote is right there. So if I have a vertical asymptote at 0, x equals 0. My slant asymptote is y equals x. So that means it's got an intercept of 0 and a slope of 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. So it's this set of dots right here. What happens when I plug in, well, do I get any horizontal or x or y intercepts, I should say? No, because the graph, I believe, is here and down here. Right? Okay. So we don't have any x-intercepts. We don't have any y-intercepts. We don't have a horizontal. Do I have symmetry?
No.
What's my graph? X squared plus 1 divided by x. If I flop this over here and then down, wouldn't it line up? Yeah. So we have symmetry about the origin. If I flop it over here, right? So if I fold on the vertical axis, it would land there. Now if I take my dotted line and fold it down, the second fold, it would land on that one. So sketch this graph. How many problems are left?
This is
This is the last one, and then
Yeah. This is definitely the last one.
we're good. You can finish the packet. You can do your worksheets.
This is the last one, yes.
Wait,
Wait. It's all.
Use it above.
That's right.